Hello, and welcome to video number 2 for AP Physics C Mechanics. The topic of discussion for this video is Unit 1.2, in which we will be looking at kinematics. In particular, we will be looking at an average velocity, average acceleration, instantaneous velocity, and instantaneous acceleration, along with the basics of calculus required to determine these concepts. So, let's jump right in and get started with displacement. Here is a position versus time graph for a car traveling along a straight road. And yes, it is absolutely necessary to have it curve that far off the page. At time t1, the car is at position x1, and later, at time t2, is at x2. The displacement delta x can be determined by subtracting x1 from x2 as shown. Now, let's have a look at average velocity. This is the displacement divided by the time interval. Mathematically, this looks like delta x over delta t, or x2 minus x1 over t2 minus t1. Graphically, the average velocity is the slope of the line connecting 2 points on the position versus time graph. If a car travels 150 meters in 10 seconds, its average velocity is 150 meters divided by 10 seconds, or 15 meters per second. Average acceleration is the change in velocity, delta v, over the change in time, delta t, which is v2 minus v1 over t2 minus t1. On a velocity versus time graph, the average acceleration is the slope of the line between 2 points. And yep, that curve is off the screen again. As an example, if a car speeds up from 10 meters per second to 30 meters per second in 4 seconds, its average acceleration is 30 minus 10 divided by 4, which is 5 meters per second squared. Now, let's cover some basic derivative information as it is needed for the rest of this video and the instantaneous material we are going to cover. A derivative measures the rate of change of a function at a specific point. Mathematically, this is simply the limit of the change in y divided by the limit of the change in x as delta x approaches 0. Graphically, with another curve to the stars above, this is the tangent line slope to the curve at any given point. Sometimes you will see a dot notation for time derivatives where x dot or x prime is the derivative of x with respect to time t, or the velocity. X double dot or x double prime would be the second derivative of x with respect to time t, which is acceleration. Instantaneous velocity is the derivative of position with respect to time. It would be the slope of the tangent line of a positive versus position versus time curve at a given point. For example, if a car's position is given by a function of x of t equals 2t squared plus 3t, then its instantaneous velocity at any time t would be dx dt, which is 4t plus 3. At 2 seconds, this would be 11 meters per second. Instantaneous acceleration is the rate of change of velocity at any moment, the derivative of velocity, which is dv dt, or the second derivative position, which is d squared x over dt squared. On a velocity versus time graph, instantaneous acceleration is the slope of the tangent line at any given point in time. Continuing our example above, the velocity v of t equals 4t plus 3. Acceleration equals dv dt, or 4 meters per second squared. The acceleration due to gravity on Earth is approximately negative 10 meters per second squared, meaning downward. And it is important we use the negative 10 because that is in our CED, not 9.8. In summary, average velocity is displacement over a time interval. Average acceleration is change in velocity over a time interval. Instantaneous velocity is the derivative of position. Instantaneous acceleration is the derivative of velocity, or the second derivative of position. And it is very important that you understand these concepts and their calculus foundations so that you can be successful in your AP Physics C course. Thank you very much for watching, and we will see you next time.